Welcome to another learning video. Today we will learn something about multiple linear regression with special interest on Facebook use cases. So, looking at regression analysis, everybody is asking, what's that? First to say, it's a statistical analytical method. And not only that, but also it's modeling relationships between one dependent and one or more independent variables. So how to apply multiple linear regression? First, we can predict and forecast unknown variables. So knowing X, for example, we can predict Y. And also, we can quantify the strength of the influencing value. So Y is influenced by multiple other variables. So, what's the mathematical formulation? In a mathematical manner, the relationship between a dependent variable and one or more independent variables looks simplified like that what we draw here. So Y equals the formula of X plus E. In this formulation, Y is the command variable. F of X is the average relation. And finally, E is the disturbance variable. So we have multiple patterns of a regression. In total, there are 4. The first is data preparation, so a plausibility check and data transformation. Secondly, we have the model fitting with the reduction of disturbance variable influences. In the third step, we have the model validation, so we do a validity check of the relationship model. And finally, on the 4th place, we have the application. So if we predict or influence the quantification. So let's move further on. So we have several types of regression models. On a high level, we have primary models, we have generalized models, and we have also special models. For primary models, we can go more into detail with linear regression, non-parametric regression, multivariate but adaptive regression spliness, semi-parametric regression, and robust regression. Generalized regression models include the generalized linear regression, generalized semi-parametric regression, and for special we have the autoregressive models. Today we will look at linear regression of primary models. So multiple linear regression is one dependent variable called Y is explained by multiple other variables x1, x2, x3 and so on for a multiple number of x's. So the x's are called multiple independent variables. So how to note a multiple linear regression? Y explained by x, x2, xn. There's Y, the dependent variable, the predictant or criteria. Yx, x2 and so on is called the independent variable, regressor or causal variable. So after all the theoretical stuff, let's bring in some math. Y equals b0 plus b1 multiplied with x1 plus several steps in the same way. So Y is the estimated value, b0 is the regression constant, b1 and so on is the regression coefficient, which is calculated by delta Y through delta X. X is therefore the causal variable. So, when talking about regression, keep in mind the following steps. Usually, causal variables correlate with each other, and regression coefficient represents the relative influence of causal variables x on the criteria y. And if x changes of a standard deviation, then y changes of the standard deviation as well. So, what questions can be answered by multiple linear regression? For example, which influence do causal variables x1, x2 and so on have on the criteria y? So in application, multilinear regression can answer: can personal characteristics be estimated by analyzing Facebook likes, for example? So looking at Facebook likes, can we predict characteristics of human beings like intelligence, sexual orientation, or political view, for example? So let's have a look at the respective Facebook use case. We had like data of 58,000 volunteers, and we entered that into linear regression to predict individual psychographic profiles with an accuracy of 90%. So what could we predict out of the likes? So likes indicating high intelligence were, for example, science, thunder, and curly fries. And likes indicating low intelligence were, for example, Harley Davidson, or a site called Keep Calm, I Love Being a Mom. So what we can say out of that is that some connections do not seem to be possible to explain rationally. But that was not only the only outcome. So we also had a look at likes indicating homosexual orientation. So uncommon likes were gay marriage, it's cool to be gay, and common likes were Britney Spears or Desperate Housewives. So only few likes directly reveal personality traits. So knowing that and knowing the Facebook use case, we know several opportunities like customer-centric product design, personalization of communication, but also risks like privacy violation and loss of trust and integrity of online applications. So many thanks for watching, and if you like it, check us out on the respective partner sites. Thank you.